In this video, I'm going to discuss multiplying radicals. So the rule that we're going to use for this is the square root of a times the square root of b equals the square root of a times b. So essentially we're taking each one of these radicands separately when being multiplied and putting them together under one radical. So the first example we're going to look at is the square root of 3 times the square root of 5. So what that's going to look like is under one radical we're going to put 3 times 5 and we're going to get the square root of 15. The next example we're going to look at is going to be the square root of 7 times the square root of 2. So again, we'll take this radicand and this radicand and put them under one radical together and multiply them. So 7 times 2 equals 14. And so it's the square root of 14. Well, in both of these cases, when we multiply 3 times 5 to get 15, 3 and 5 are both prime numbers. Also, 7 times 2 to get 14, 7 and 2 are both prime numbers. This means that 15 and 14, when you do the prime factorization, it's just two prime numbers that are both unlike. So neither one of them are the same, so they won't pair up and simplify the radical. So another example, if we take the square root of 6 times the square root of 15 and multiply those together, we'll see that we have 6 times 15 under one radical. However, in this case, our 6 will be 3 times 2 and our 15 will be 3 times 5. So under one radical right now, we actually have 2 times 3 times 3 times 5. Which right here, now we do have a pair of 3's, so that'll come out to give us 3 times the square root of 2 times 5, which will end up being 3 times the square root of 10. So sometimes when you're multiplying these radicals, you can have things that simplify. So I would encourage you not to multiply 6 times 15 to get the square root of 90, which it does equal the square root of 90. Here's why I would encourage you not to do this. Because then you're going to take 90 and do the prime factorization of it anyway, so you're going to be dividing all this stuff out. So why don't you just save yourself the trouble and go ahead and divide it out of these two smaller numbers and find the prime factorization of 6 and the prime factorization of 15 and then put them both together under one radical. That way you can look for pairs then and simplify as necessary. So another example then, let's do the square root of 10 times the square root of 14. Again, we'll have the square root of 10 times 14. And 10 will break down to 2 times 5. And 14 will break down to 2 times 7. So when we put this under one radical together, it'll be 2 times 2 times 5 times 7 when we put them in order from least to greatest. And again, we have a pair of 2's, so the 2's will come out. And inside we have a 5 and a 7 left over. So our final answer should be 2 times the square root of 35. The next example that we're going to look at is 5 radical 2 times 4 radical 3. So this one has more than just radicals that we're multiplying. It's got these whole numbers on the front too. So here's how we're going to do this. We're going to multiply the whole numbers just like we ordinarily would. So 5 times 4 will be 20. And then we'll deal with the radicals and say the square root of 2 times the square root of 3 is the square root of 2 times 3. And 2 times 3 can't simplify because there's no pairs. So really we'll just get 20 times the square root of 6. And that's what that will look like when you have a whole numbers and you have the radicals to multiply. In this example, we have 13 times the square root of 5 times the square root of 7. So this first term has a whole number out front, and then the other terms are just radicals. So since there are no other whole numbers, this whole number is just going to come down for the ride, so 13, and then the radicals will become 5 times 7, which we're not going to have any like terms here or any pairs that we can pull out, so this will end up just being 13 times the square root of 5 times 7, which is 35. In this next example, you'll see that we're going to include variables underneath our radical. This will not, however, change how we simplify these radicals when we multiply them together. So we still got this guy multiplied by this guy, so we're going to put them under one big radical and say 2x cubed times 6x to the fourth. So in the previous examples, at this point we would take each one of these separately and find the prime factorization instead of multiplying them together and then finding the prime factorization. There's just that little unnecessary step of multiplying them together, especially since we're just going to be breaking them back down again. So 2x cubed will actually be 2 times x times x times x, and 6x to the fourth will be 2 times 3 times x times x times x times x. And again, in previous videos we have discussed that we don't have to write all of these x's out, but for our sake right now we're just going to go ahead and do it and take a look at what happens. So looking for pairs of numbers, here's a pair of x's, here's a pair of x's, here's a pair of x's, and actually we have a pair of 2's way over here as well. Even though they're not right next to each other, that's okay, we can still pair them up. And what's left over is this x and this 3. So what does that look like? Well, we have a pair of 2's that came out, and we have this pair of x's that came out, this pair of x's, and this pair of x's. So we actually had 3 pairs of x's, and what was left on the inside was a 3 and an x. So when we simplify this, finally now we have 2 and then x, which is going to be 2x cubed, and left over in the radical is a 3x. So when we simplify the square root of 2x cubed times the square root of 6x to the fourth, we're going to get 2x cubed times the square root of 3x. The next example is negative x squared times the square root of 6x cubed times 2 times the square root of 3x. So again, like the previous examples, we will multiply what's out front of each radical by one another, and then we'll do with the radicals. So negative x squared times 2 will make negative 2x squared. And then inside the radicals now, we have 6, which really is 2 times 3, and then 3x's, and then the other one is 3x. So we're going to see what kind of things we can pair up. So if we change the order of these, it looks like we'll have 2 times 3 with 4 x's when we put them from least to greatest, and then the variables follow at the end. So it looks like we have a pair of 3's, a pair of x's, and another pair of x's. And the only thing that sticks around is this 2. So the 3 comes out, and then 2 sets of x's come out. So on the outside already we have 2x squared, and a 3 will come out, and 2 more x's will come out, and then what's left over on the inside is the 2 right there. Okay, so when we multiply all this stuff together on the outside, we have negative 2 times 3 is negative 6. X squared times x, it makes 2, 3, 4 x's, and on the inside is just this square root of 2 here. So our answer to this one is negative 6x to the fourth times the square root of 2. The next example will be 5 times the cubed root of 18y times 2 times the cubed root of 3y squared. So again, we will take what's outside and go ahead and multiply those things together. So 5 times 2 will be 10. And then on the inside, because this is going to be the cubed root of this business, 18 can break down to 2 times 3 times 3. And if you want to, you can go ahead and do the prime factorization and just make sure that. And then times that y. And then we have 3y squared over here. So when we put it all together, we'll have 2 times 3 times 3, the two 3's from here, and the single 3 from here. And then how many y's? 1, 2, 3. So 3 y's. Now in this case, this is the cubed root, so we're taking groups of 3. So we have 3 3's and 3 y's. So when we take those to the outside, it looks like we'll have 10 times 3 times y. And on the inside, we just have this 2 left over that didn't go with anybody. So now we can say our final answer is 10 times 3 is 30, and then the y, and then the cubed root of 2. So the answer to this problem is 30y times the cubed root of 2.